We've never detected a magnetic field around an asteroid, but we've measured magnetization in meteorite samples.
I can remember so clearly the day that we talked about the concept that actually led to the mission. I had just finished teaching a course, and I came out of the classroom, and Ben was standing there, his office was right there, and he said, "Lindy, we just made a measurement from this meteorite that shows that it has a magnetic field that it recorded from back at the time of its formation. We don't understand how this could happen. Can we talk about it for a minute? Maybe you have some ideas." And I was like, "I totally have an idea. It's based on what I was just teaching." And we sat down in his office and we drew things on the whiteboard, and suddenly we had this idea about how planetesimals could form.
We wrote a paper about this idea. That paper was read by Daniel Wenkert and Bruce Bills at JPL, who actually ended up contacting us and proposing to build a mission around it. Psyche represents one of the best opportunities we will have to search for the first evidence of asteroid magnetism. It's now long frozen, billions of years ago, but that ancient magnetic field that it could have generated could be imprinted in the surface layers of Psyche, which cooled in the presence of this field. And so they would have what we call magnetization, which is like a fossil or an echo of the ancient magnetic field that it generated. And the way you sense magnetic fields is you use an instrument called a magnetometer, and that's what we have on Psyche.
The Psyche team contacted us because they know we have a very high quality magnetometer based on the magnetic materials that we are producing.
So we have a huge experience in how to do this and how to drive space magnetometers on very long time scales. Here we are talking many, many years.
We build the hardware, we qualify the hardware here on ground, we calibrate the hardware, and then we deliver it to the Psyche. And MIT is responsible for the science, operations, and data processing of the magnetometer from Psyche.
The magnetometer is on the whole time. It turns on after launch. It's on for the whole mission. And so we'll have a lot of time to observe the signals from the spacecraft and to calibrate for those. So by the time we actually get to Psyche, we'll be able to get a good, clean measurement of the asteroid's magnetic field.
So my role was to model the interaction of the asteroid with the solar wind and then kind of fly, I simulated Psyche to fly through this simulated asteroid. This is a 3D print of Psyche. So if this asteroid is magnetized, you can imagine a magnetic field around it, kind of like the Earth's magnetic field, like a big bubble, but like smaller. And then you're going to have the solar wind flying around it, a bunch of electrons and protons coming in from the sun, interacting with this magnetic field and changing it constantly. And then we're kind of flying in a small computer-generated spacecraft that is going to measure this magnetic field while everything is changing and analyze it and say, are we going to be able to tell if there's a magnetic field coming in from this body, or are we just seeing all of this space magnetic field around it?
The real precise mapping we expect to do when we are closest in on the asteroid, when we are really orbiting close in the final science orbit.
But it's possible that Psyche is so magnetic that we could even detect its field before we go into orbit. That's conceivable.
This is my first opportunity to actually be involved with that process of designing the investigation and figuring out how to clean up that data so it will be usable by the science community at large.
An important part of building a space mission is to imagine the whole range of possibilities and to build for all of them.
A big part of the spirit of the team is to talk across disciplines. I get a chance to share my science with this very broad group of people.
Everybody on this mission is dedicated in a way you rarely ever see anywhere else. And that actually makes a huge difference when you are trying to achieve a goal this difficult.
Never did I ever imagine that I would actually be involved in a project to actually send a spacecraft up to an asteroid. Being able to basically be part what feels like live science fiction is something that for me that I really enjoy about this.
If we can do things like send this robotic orbiter out to this asteroid so far away to learn things that we cannot learn in person, then surely we can solve these problems that are in front of us here on Earth that we can actually put our hands on.